Hello everyone. I've received a couple of questions regarding this question in exercise 7b. So I'll use this as an example to go through for one more example and then to clarify the other few points regarding things like actual significance levels, critical values, critical regions and so forth. So I'll clarify those at the end of the question as well for you. But in brief, this question, as you can see there, is binomially distributed where n is 20, and we are testing the null hypothesis here, that the probability of something happening is 0.4, and here the alternate hypothesis is the probability that it doesn't equal 0.4. So the doesn't equal makes it a two-tailed test. So our 5% level of significance that we're asked to check for this question is going to be split at 2.5% each end. Now, when you're asked to find a critical region, as I said in class, I think it's still useful to use the distribution tables, which you will be given in your exam. So what I've done here is highlighted the table where n equals 20, okay, and the probability I've just highlighted. This is the column where the probability is 0.4, which we'll use for this question. Now, as I said to you in class, the first part is fairly straightforward. You can see here as we go up, so we've got x equals 0, x equals 1, x equals 2, and x equals 3. And we are looking up to 2.5%. Remembering that these are the cumulative distributions, which is what we're looking for. So you can see there from the table that the probability that x is less than or equal to 3 is going to equal 0.0160, which effectively is 1.6%. And if we go up to the probability that x is less than or equal to 4, we have the probability is 0.0510, which is 5.1%. Now, this is a two-tailed test. In fact, it would be the same answer in this case, whether it was a single-tailed test or a two-tailed test, because obviously that's over 5% as well anyway. So the final value we can get to for x is 3, which keeps us within inside the significance level of 2.5%. So our critical region for the lower tail is going to be x is less than or equal to 3. So what we're saying there is, at this significance level, we are saying that if in a sample that's taken, let's for example say that there's 20, computers, and the probability that they'll develop a fault within, say, 2 years is 0.4. So if we take a sample of 20, and we find out that after 2 years that 0, 1, 2 or 3 machines develop a fault, then there is evidence to suggest that the null hypothesis is incorrect. Okay, so that's what we mean by this critical region. Now, just to clarify what the critical value would be, the critical value, I know it doesn't ask this in this question, but just to clarify all of the different terminology, the critical value would be x equals 3. It's the final value before we lose that level of significance. Okay, but for this question, for the critical region, we've got x is less than or equal to 3. Now at the other end, we're looking at the 97.5% mark. Okay, but we've got to remember here, if I just count down, so we've got 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is where x equals 12. Okay. So we can say that the probability that x is less than or equal to 12 is going to be 0.9790, because obviously our distribution tables tell us the values where we're less than or equal to that value for x. Now that means, if you remember, sometimes it's useful just to see it as a number line as well. So the probability of less than or equal to 12, so going in that direction, is going to be 0.9790. So the probability that x is greater than or equal to 13 is 1 minus the probability that x is less than or equal to 12. So 1 minus 0.9790 is going to give us an answer of 0.021, which is effectively 2.1%. And we can see that is the start of our critical region at the upper tail. So you've just got to be careful. You don't just pick the number, the value for x. You've got to remember what the actual distribution tables actually tell us. So the critical region for the upper tail is therefore x is greater than or equal to 13. And the critical value will be the first value in the region again, so x equals 13. Now for this question, if it asks for, which I think it does in this question, the actual significance level of the test. So for part B, so we've got our critical region is x is less than or equal to 3 and x is greater than or equal to 13. So again, before I go on to part B, what we're saying is in that sample of 20 computers we talked about earlier, if 13 or more develop a fault within 2 years, then there is enough evidence again to suggest that the null hypothesis is actually not correct. Therefore, the alternate hypothesis, we would take that the probability is actually not equal to 0.4. Okay, and then the actual significance level of the test, you actually pull off your final values there. So if you remember from before, we had actually the 1.6% there. So we've got 0.016 at the lower end, and then we've got plus 0.021 at the upper end. So our significance level for the test, we just add those together, which is 0.037 or 3.7%. So that's the actual significance level for the test. And again, it's fairly clear to see that if you end up with an answer that is actually greater than your test, so we're asked to test at the 5% level of significance, then something's clearly gone wrong. So I hope by going through that question, it's obviously another example for you anyway, but hopefully that clarifies the difference that some people have been emailing about critical regions, critical values, and indeed the actual significance level of the test. Good luck with the exercise, everyone.